Now let's look at recursion. And if you haven't seen recursion before, this is a topic that typically takes a few times looking at this for it to really start to click. So what is recursion? My favorite definition of recursion is that it is a function that calls itself until it doesn't. So now let's look at a very common example that is used to explain recursion. I'm going to bring up a gift box here, and we need to open the gift box. And the way we open gift boxes is with the open gift box function. And when we run the open gift box function, it's going to return either a ball, in this case, or it's going to contain a smaller gift box. And if it's a smaller gift box, the way we open gift boxes is with the open gift box function. So we'll run that again. And when we do, that gift box is either going to contain the ball or it will contain a new, smaller gift box. So now we're going to run the open gift box function again. And in this case, we'll just say that we found the ball. Okay, so now let's put this back and we'll look at some code. Now I want to emphasize this is pseudocode. This is not code that will actually run. It's just for example. So we're going to create our function open gift box. And we're going to say if when we open the box, it contains a ball. So if ball, we will return that ball. Otherwise, it's a gift box, in which case we need to run the open gift box function. And this is where the function calls itself. So there are a couple of things about recursion that are very important. First, the process of opening each new box is the same, or the process of whatever we're doing with recursion has to be the same. The other key point is each time we open a box, we make the problem smaller. So now let's walk through this code with our boxes. So we'll say open gift box, and when we do, we'll check to see, is this a ball? In this case, it's not, so we have to run the open gift box function again. So it calls itself. So this is a second instance of the function that we're putting on the call stack. And we'll talk about call stacks further in the next video. So then we're going to check to see if this box contains a ball. It does not. So we have to run another instance of open gift box. This is going to call itself again. So now we run another instance of the function. Now, when we check to see if it's a ball, it is a ball. And because this is a return, we will not run this line of code, and we stop having the function call itself because we have this return method here. So you have to have this in your recursive function. So now let's put this back again and talk about a couple of concepts here. When we open this box and it contains the ball, this is what we call our base case. This is when we are going to stop opening boxes, or the function will stop calling itself. If it needs to call itself again, this is called a recursive case. This is also a recursive case, and this is the base case. Let's bring our code back in here. When this if statement is true, that is our base case. And it's very important to have this, because if you don't, we'll remove this, the function gets called, and then it calls itself, which creates another instance of the function, and that's going to call itself, and then we create another instance of the function, and so on. And this will create what is known as a stack overflow. So you have to have a base case where this will at some point stop calling itself. And there are a couple of things about this that are very important. First, this if statement has to be true at some point. So you can't have something like this, because 1 is never greater than 2. This will never be true. and you will loop through this infinitely and create a Stack Overflow. And you might be saying, well, that's pretty obvious that 1 is never going to be greater than 2, but sometimes we have if statements in our code that are very complicated, and it's not obvious that the if statement is not going to ever be true. So if you get a Stack Overflow in a recursive function, this is one of the places to go troubleshoot. So let's put this back. The other thing is that you have to have a return statement. If you have something like this that doesn't return anything, the if statement becomes true, you print hello world, and because it is not a return statement that causes us to stop running code, it just goes right to the next line, and we go right back into our loop and have a Stack Overflow. So it's very important that you have the return statement in your code. And that is our quick overview of recursion.